The topic of this lesson is loan length formula. We're going to be examining a new formula today, and this formula allows us to determine the time in years that it will take to pay off a specific loan given a specific monthly payment amount and a specific interest rate. Now, this is important because oftentimes people will have in mind how much they can pay per month, right, given the amount they're borrowing. And so this formula will actually determine how long you will have to pay this if you already know the monthly payment amount that you're looking for. So this formula really is just a modification of our monthly payment formula in which we've solved for the variable t. So t being time in years. We have here t is equal to log of m over p minus log of m over p minus r over 12 all over 12 times log of 1 plus r over 12, where t is time in years, m is the monthly payment, p is the principal or the amount borrowed, and r is our annual interest rate. Let's take a look at an example of how to use this. Okay, example 1. Claude wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that all he can afford to pay per month is $300. The bank is offering a 5.9% interest loan. What would the length of his loan need to be so that he could stay within his budget? Now, just note this is very common. When you go to a car dealer or go to a bank to finance a loan for a car or a home, generally one of the questions they ask you is how much can you afford per month? And you need to be careful with this because they know how to make the numbers work, right? So they will determine the length of time, no matter how long, right, in order to make this affordable for you. Now, do note, even though the monthly payment may be affordable, you might end up paying for this car, this home, for an extra 5 years, right, extra 10 years, and so on, and ultimately pay way more for the vehicle or the home. Okay, so let's take a look at our formula. So we're going to be using this time formula, right, which is just a modification or adaptation of our monthly payment formula. So we've solved for t. And the first thing we want to do is we want to identify what we know. So let's start with what is our monthly payment? If we look closely, we can see here that it says we're paying per month $300. That's all that Claude can afford. So that's going to be our M. And the next thing we want to find is our principal. How much is actually going to be borrowed? We can see here that's $25,000. So that's our principal or P. Now, what is our rate, right? What percent interest rate are we being offered here? And that's a 5.9. Now, do note when we plug this in, we always plug in the decimal version of the percent, so it will be a 0.059. So we're going to take all that information and we're going to plug it into our formula. Now, just like we normally do, I recommend using the Desmos calculator and type it in exactly as you see. I also recommend parentheses around both the numerator and then around the denominator to really clearly identify the separation between those two. Once we calculate this, we get that t is approximately 8.96. So we can say that Claude would need to take out a loan for about 9 years. Now it's your turn to try. In example 1, what impact would an increase in the monthly payment of $50 have on the length of the loan?